So now we're going to get on to multiplying vectors. So in multiplying vectors, there are two ways that you can multiply the vectors. One of them is called the dot product, which we will cover, and one of them is called the cross product or vector product, which won't be covered here because it involves matrices and it's a slightly complex process to do. But anyways, the dot product is one of the two ways you can multiply vectors. It's also called the scalar product because it outputs a scalar. You could probably tell what the cross product would do if it's known as the vector product. So it comes in two distinct forms. Both of them can be used in tandem if you want to find the angle subtended between two vectors. And here they are. If v is ai plus bj and w is ci plus dj, then v dot w, this little dot operator is the dot product, is ac plus bd. So the first way is to multiply the two I components together and add them to the j components. Or you can take the magnitude of v times the magnitude of w multiplied by the cosine of the angle between them, alpha. Now, in this case, alpha actually represents the angle inside of the vectors. So the diagram down here, this is that angle alpha. So alpha can be found in a couple of different ways. You can do the angle here, say beta, and take it away from this angle theta to get alpha. Or you can use the dot product, which gets a slightly more accurate result in case beta and theta are all really weird numbers. So you can rearrange the second part to isolate cos alpha. The way you do that, I'll do it up the top here. So v dot w is mod v times mod u cos alpha. If you just divide by the magnitudes, you just get cos alpha is v dot w divided by the product of their magnitudes. And that's a slightly easier way to represent the cosine of the angle. As well as that, you'd probably be asked as well maybe for the sine of the angle in between them, or the tan of the angle between them. So if you remember cos alpha, then you can form a right angle triangle and find sine and tan alpha. Dot product questions can be slightly tedious, but there are 3 examples that are coming up.